I like to think about these kinds of problems because they make you examine what you actually know and what you're just assuming. Let me start by laying out some basic facts about what we're really talking about. The Milky Way galaxy, that's our galaxy, the one we live in, contains somewhere around 200 to 400 billion stars. That's a staggering number, 400 billion. And we've discovered in just the last couple of decades that most of these stars have planets around them. So we're not just talking about 2 or 3 special cases where planets exist. We're talking about planets being the normal situation. Billions and billions of planets. Now, the Milky Way itself is about 13 billion years old. Our solar system, by comparison, is about 4.5 billion years old. So there's been plenty of time, far more time than humanity has been around, for other civilizations to develop on other worlds. There's also plenty of time for them to spread out, to explore, to colonize other star systems. If you had a civilization that was only slightly more advanced than we are, if they could build spaceships that could travel at just 1% of the speed of light, which is actually not that fast when you think about the speed of light, they could colonize the entire galaxy in just a few tens of millions of years. A few tens of millions of years. Compared to the billions of years that have been available, that's nothing. That's like a few seconds on a clock that's been running for a whole year. So here's the paradox. If there are civilizations out there, and statistically there really should be, then some of them should have spread throughout the galaxy by now. They should be everywhere. We should see signs of them, massive engineering projects, radio signals, something. But we don't. We look out at the universe, and it's quiet. It's silent, and that silence is the puzzle. Now, what does this tell us? Either there's something wrong with our assumptions, or there are some pretty powerful barriers that prevent civilizations from spreading across the stars. This is what people call the Fermi paradox, or sometimes the Great Silence. Let me tell you about some of the explanations that scientists have come up with, because they're actually quite interesting to think through, and I want you to notice something as I talk about them. Many of these explanations require us to imagine some pretty dramatic barriers, some pretty fundamental obstacles. One explanation is that we simply haven't listened long enough or in the right way. Humans have only been listening for radio signals from space since about 1960. That's about 60, 70 years. The universe is billions of years old. So maybe an alien civilization broadcast a signal a billion years ago, and we just weren't here to hear it. Maybe they're broadcasting right now on frequencies we don't know how to listen to. Maybe they're using methods of communication that we haven't even thought of yet. Neutrino beams, or something we haven't discovered. In this case, the silence doesn't mean nobody's out there. It just means we're not listening the right way. But here's an interesting thing to consider. This explanation requires that advanced civilizations don't use the obvious methods of communication. If I were trying to talk to someone in another star system, I think radio waves would be one of the first things I'd try. They're electromagnetic radiation. They travel at the speed of light. They carry information well. It seems like the obvious choice. So if nobody's using them, well, that's interesting, isn't it? That tells you something about what advanced civilizations might be like. Another explanation is what people call the Great Filter. The idea here is that there's some barrier, some evolutionary wall that most life forms can't get past. And there are really 2 possibilities with this idea. One is that the filter is behind us. Maybe life itself is incredibly rare. Maybe the jump from chemistry to biology, or from simple life to complex life, or from simple animals to intelligent animals. Maybe one of these jumps is so unlikely that it almost never happens. In that case, we might actually be one of the only intelligent species in the galaxy. We'd be special and rare. That would explain the silence. There's not much to listen to because we're almost alone. But the other possibility, and this one is a bit sobering, is that the Great Filter is ahead of us. That means that advanced civilizations reach a certain point, and then they hit a wall. They destroy themselves, or they stagnate, or something happens that prevents them from spreading out and being detectable. If that's true, then it means we're going to hit that wall too, eventually. It's not a comforting thought, but it's worth considering. Now here's something else that people don't think about as much. There's the question of time. The distances between stars are so enormous that they're hard to really visualize. I'll give you a concrete example. Our nearest star, Proxima Centauri, is about 4 light years away. That means light takes 4 years to get there. If you sent a spaceship traveling at 10% of the speed of light, which would be a tremendous achievement for us, it would take 40 years to get there. 40 years. That's a long time to travel, but it's not impossible. But here's the thing. Even if advanced civilizations are out there, and even if they have the technology to make those journeys, there's no guarantee that they would be expanding outward at the same time that we're listening. Maybe civilization A expanded 2 billion years ago. Maybe civilization B is expanding right now, in another part of the galaxy. But the odds that we'd overlap in both space and time, the odds that they'd be right here, right now, trying to reach us, those odds are actually quite small when you think about the whole volume of the galaxy and the whole span of time available. It's a bit like if I threw a pencil across a vast room and you threw a pencil at the same time. What's the probability that they'd hit each other in midair? It's not impossible, but it's not very likely unless you're aiming at each other. Now, some scientists have imagined that if a civilization wanted to explore the galaxy thoroughly, they wouldn't send crewed ships. They'd send robots, self-replicating probes. Think about it. You build a spacecraft with an artificial intelligence inside. You send it to another star. When it gets there, it uses the resources from that star system to build 2 copies of itself. Those 2 copies go to 2 different star systems and build 2 copies each. 4 copies go to 4 different stars and build 8 copies. 8 becomes 16, 16 become 32. This exponential growth would spread through the galaxy incredibly fast. You could populate the entire galaxy with robot probes in just a few million years. And these probes would be very detectable. They'd be using resources, extracting material from planets, doing massive engineering. We would see evidence of them, but we don't see any evidence. The sky is dark. The stars are just stars, as far as we can tell. So maybe advanced civilizations don't want to expand. Maybe they don't have the motivation. Maybe once you reach a certain level of technology, you don't want to colonize other star systems anymore. Maybe you'd rather stay home and enjoy what you have. Maybe you build simulations, virtual worlds inside computers, and you don't care about the physical universe anymore. Maybe you even upload your consciousness into a computer and live forever in some digital realm. That would explain why we don't see them expanding. They just don't want to. Or maybe they stay quiet on purpose. There's a concept that some scientists have talked about called the dark forest. The idea is this. Imagine that space is like a dark forest and civilizations are like hunters. You don't know if the other hunters in the forest are friendly or hostile, so you stay quiet. You don't send out signals, because a signal might attract a dangerous civilization. You hide. You hope nobody finds you. And everyone else is doing the same thing. In this scenario, the universe is full of civilizations, but they're all hiding from each other. They're all quiet. And that's why we see silence. Now, let's talk about what would actually have to happen if an alien civilization wanted to reach us. What would have to be true? Let's think through the physics. The distance to the nearest star system is about 4.5 light years. We don't have any way to travel faster than light. Einstein's theory of relativity seems pretty firm on that point. So the minimum travel time with a crewed mission would be many decades. Probably at least 40 or 50 years if you're traveling fast, assuming you have some kind of propulsion system that's much more advanced than anything we have. Now, what kind of propulsion systems could theoretically work? Well, the most basic idea is chemical rockets, like we use now, and immediately you run into a problem. It's called the rocket equation. The amount of fuel you need grows exponentially with the distance you want to travel. To send a single human to the nearest star using chemical rockets, the amount of fuel required would be more than the mass of the entire observable universe. This isn't hyperbole. It's actual physics. Freeman Dyson, a great physicist, said, "Chemical fuels are hopeless for interstellar travel." And he's right. So what else could you do? Well, nuclear fusion is a lot more efficient than chemical combustion. A fusion rocket could theoretically reach speeds of around 10% the speed of light. That's a fantastic improvement, and it's not physically impossible. You're talking about using the same process that powers the sun to power a spaceship. That's not easy, but it's not magic either. If you had a technology like that, you could reach Proxima Centauri in about 40 years. But there's another interesting propulsion concept that I think is worth talking about. It's called a light sail. The idea is simple. Light has momentum. Even though photons don't have mass, they do have energy and momentum, and they exert a force when they hit something. If you had a huge, incredibly thin sail made of something like graphene, and you pointed an extremely powerful laser at it, the light would push the sail. You could accelerate the sail to a significant fraction of the speed of light. Now, there's a project called Breakthrough Starshot that's trying to develop this technology. The idea is to build a spacecraft about the size of a postage stamp, incredibly small, and launch it to another star using a laser beam from Earth. They think you could get it up to 20% of the speed of light, which means it could reach Proxima Centauri in about 20 years. But here's the catch. You need a laser that consumes the energy output of every nuclear power plant in the United States, operating for 10 minutes straight. And we've never operated a laser for 10 minutes. The most powerful lasers we have operate for a few seconds or maybe a few milliseconds. So think about what that tells you. Even with a brilliant idea like a light sail, which should be easier than a chemical rocket or even a fusion rocket, you need an enormous amount of power that we can't currently generate. Now, for an alien civilization that's thousands of years ahead of us, maybe they can do this. Maybe they can build giant laser arrays. Or maybe they've discovered fusion power and can generate enormous amounts of energy. But the point is, even for an alien civilization, traveling to other star systems is not easy. It requires vast amounts of energy. It requires incredible engineering. It's not something you do casually, the way we send ships across the ocean. There are some more exotic propulsion concepts that people talk about. Antimatter, for instance. If you could somehow create antimatter and store it, and then combine it with regular matter, you'd get a reaction that converts mass directly to energy with incredible efficiency. Einstein's famous equation tells us how much energy that is. But creating and storing antimatter is something we can barely do at all, and we can only create tiny amounts. An alien civilization far in the future might have figured this out, but we certainly haven't. There's also the idea of wormholes. Einstein's equations allow for the possibility of wormholes, bridges through space-time that could connect two distant regions of space. But there are some serious problems. Wormholes appear to be unstable. They would collapse as soon as you try to pass through them. And even if you could stabilize them, you'd need something called exotic matter, which might not even be real. This exotic matter would have negative energy density, anti-gravity properties. We've never seen anything like it. So while wormholes aren't ruled out by the known laws of physics, they're not something you could actually use. Then there are the more speculative ideas like warp drives. There's a mathematical model called the Alcubierre metric that shows that in principle, space-time could be warped in such a way that a spacecraft could ride inside a warp bubble. Space would contract in front of the ship and expand behind it, and the ship wouldn't exceed the speed of light locally. It would just be carried along as space itself moves. On paper, the math works out, but in practice, you'd need amounts of exotic matter, negative energy, that exceed the entire energy content of the observable universe. So while it's not forbidden by the laws of physics we know, it's so far beyond what seems technologically possible that we might as well consider it magic. What all of this tells us is something pretty interesting. Even if you're a civilization thousands of years more advanced than we are, traveling between the stars is hard. It's not impossible, but it's hard. It takes enormous amounts of energy. It takes incredible engineering. So if an alien civilization wanted to reach us, wanted to overcome all these barriers, they would have to have a reason. They would have to have some motivation. What would motivate them? Maybe scientific curiosity. We explore, don't we? We're driven to understand the universe, to see what's out there. Maybe they are too. Maybe there are alien scientists who want to know if there's intelligent life on Earth, and they've set out on a journey across the light years just to find out. Or maybe there's something about our planet that attracts them. Maybe we have resources that are rare. Maybe we have some unique form of life. Maybe they're looking for habitable planets to colonize, and our world looks like a good spot to them. Or maybe they're just explorers. Maybe they're driven by the same urge that drives us. The urge to see what's over the next hill, to go where no one has gone before. But here's the interesting thing. If they did manage to reach us, what would they find? They'd find a planet with 4 billion humans living on it. They'd find a civilization that's developed technology and culture and science. They'd find beings with curiosity and consciousness, with the ability to think and feel and create. What would happen if they contacted us? That's a question that's probably occurred to you. It's certainly occurred to many scientists and philosophers. Some people worry that contact would be harmful to us. Maybe their civilization would be aggressively expansionist, and they'd see Earth as a resource to be exploited. Maybe they'd view us the way we sometimes view animals, as something less than conscious beings to be managed. That's scary to think about. But there's another possibility. Maybe they'd be benevolent. Maybe they'd share knowledge with us, help us solve our problems, teach us advanced technology. That would be wonderful. Or maybe they'd be completely indifferent to us. Maybe to them, humans would be like ants, interesting to observe, but not worth interacting with. There's also the thought that if advanced civilizations do exist, maybe they have a rule about not contacting young civilizations like ours. Some people call this the zoo hypothesis. The idea is that we're in a cosmic zoo or nature preserve. The aliens are watching us, but they're not interfering with our natural development. They're letting us grow and evolve on our own. Now, there's something I want to point out about all of these scenarios. They all require that an alien civilization goes to tremendous effort and expense to reach us. They have to overcome enormous barriers of distance and energy. They have to make a decision that it's worth their time and resources. They have to choose to contact us. Given how hard it would be to make that journey, given the enormous amount of energy and technology required, they would have to really want to reach us. They would have to have a compelling reason. And you know what? Maybe they did reach us. Maybe they're here right now, or they've been here in the past, and we just didn't recognize them. That's an interesting thought, isn't it? We look for signs of alien life in the usual places. We listen for radio signals. We look for large engineering projects, Dyson spheres around stars. But what if they're here and they're hiding? What if their technology is so advanced that it looks like magic to us, something we couldn't possibly understand? There's a famous saying by Arthur C. Clarke: any sufficiently advanced technology is indistinguishable from magic. Maybe that's true. Maybe aliens could be manipulating atoms, manipulating space itself, and we think it was some kind of natural phenomenon. Or maybe they're not here in the physical sense. Maybe they exist in some form we haven't thought about. Maybe they're post-biological, digital intelligences living inside computers or in some kind of extended network through space. Maybe they experience reality in ways that are completely foreign to us. Or maybe, and this is the simplest explanation, maybe they're just not here. Maybe the barriers to reaching other star systems are so great that advanced civilizations simply don't bother. Maybe they stay home. Maybe they find everything they need in their own star system. Maybe they're not interested in exploring or colonizing. Maybe they're content where they are. I find all of these questions fascinating because they make you think about what's really possible in the universe. They make you examine your assumptions. They make you realize how much we don't know. The truth is, we don't have answers to these questions yet. The universe is still mostly a mystery to us. We're like children looking out at an ocean, trying to understand what's really out there. But what we can say is this: if an alien civilization wanted to find a way to reach us, if they really tried, if they committed the resources and the engineering expertise, I believe it would be possible. It would be difficult and expensive, but possible. The laws of physics don't forbid it. And maybe that's the real question we should be asking. Not just, are there aliens out there? But if there are, would they bother to find a way to reach us? What would have to be true for that to happen? Because the universe is large and it's old, and as far as we know, Earth is the only place in the universe where we know for certain that intelligent life exists. We are it, at least as far as we can tell. And that's either the most wonderful thing or the loneliest thing you can imagine, depending on how you look at it. The silence of the night sky has bothered philosophers and scientists for centuries. And maybe someday, we'll understand what that silence means. Maybe someday we'll find out that we're not alone. Or maybe we'll discover that the barriers are so great that civilizations really do stay isolated from each other, separated by vast distances that they choose not to cross. But until then, we're left wondering, and I think that's okay. I think wondering about things, asking questions that we don't have answers to yet, that's what science is really about. It's about curiosity. It's about looking at the universe and saying, how can that be? What does that mean? What if aliens found a way? I guess we'll have to keep listening.